I thought I'd do a little video on some new tools I've been using to create an instrument panel for my scale plane. And I borrowed heavily from the old an old JTech set of instruments I had from the 80s, and I think this really borrows on an old Dave Platt technique. But the important thing here is this little representation of the stack up. This is the cross section of the instrument panel and the hull, and then this little thing here is the lens, and then whatever you have under it with your decal or whatever. But the thing of interest is this lens, and this is what they used to give you. The new JTech, I'm not sure they even do this. Looks like, this is vacuformed, and I'm trying to figure out how to make this, because I'll show you in a minute why this is so important. And I'm trying to figure out how they do it, and then it hit me that this little line was likely made by a standard size of K&S tubing, and sure enough, I found it, and all of these are standard sizes of brass tubing. So I haven't seen exactly how the machine works, but that kind of led me to it. And the reason this is important is what you're trying to simulate here is this bezel. Now, I used to think instruments went in the panel and you saw all this here, and maybe it does in some planes, but on the one I'm doing, the hole that comes in through the back and you screw through the instrument panel. But the importance of this bezel, it's showing up, and also the importance of where this glass is in relation to the instrument panel and the height, it really seems to be important to selling the authenticity of this. Also, like Dave Platt always said, the pointers add a lot to it, so I wanted three-dimensional pointers as well. So controlling this thing became a big issue. So I created a little plan of how to do it. So this would represent a little Vacuform plug. This is the base of your Vacuform machine. Anybody's done it, you kind of need these things to be tall so the plastic will drape down. But when you're done and you pull it off, this is what you get. This is that little lens that I was showing you before. So as you can imagine, this is kind of what this is, but in a little different format. And what you're able to do here is this basically, I modeled kind of this plug, and the design is such that I could really set the height and the width, the diameter, and then have this little piece here that sets this bezel. The key though are these air passages. This is 3D printed. I designed it in a CAD program called Fusion 360. This becomes the face of the lens, so I polish that down to maybe 2000 grit. Just takes a couple seconds, but what's hard to see is a series of holes, tiny holes. I mean, they're probably 4,000 or 5 thousandths. I don't even know how big they are. They're really small, but they go right around, and they straddle this piece of brass, and what they do is they pull a vacuum inside there, and here they pull a vacuum in here, and they pull a vacuum here. So they get you this edge here, and they get you this real tight, almost a 90 degree, but you get very well defined, and that's very important. And so when you're done, you end up with a little piece like this, which is the lens, and then you have to pull this little ring out and then you start trimming it, and you can trim it roughly, and then you paint the inside of it. I also paint the outside of it. Turns out you need to put dull coat on the outside, or it kind of looks funky. But that little mask there is also made. All this is made from the same database. That's how you're able to make this stuff so precise. So I try to figure out how to trim this, because you'll see in a minute it's very important that all the dimensions of this thing be accurate. So the very last thing you do is you put it in this little holder, and there's one of these for every size, and you drop it in, and then you can just sand it on a piece of sandpaper and set this height. And when you're done with that, then you end up with a little bezel that's a perfect thickness. So that's very important. Now if you look at how the instrument itself works, this is the FR4 instrument panel. This is the back of it. The hole there is cut on a desktop little CNC machine. You probably get for $250. And this is all designed in CAD, again, same database in that hole. And then that's the hole in the board, and then this is the lens here that we just went through. That's the lens, and then the piece I didn't show you yet is this piece here. And this ends up setting, it captures a few things. It captures the lens, it sets the height, and these are very, very precise. I can get these dimensions here to within just a couple of thousandths of an inch. And this exaggerates the fact that this little plug is the instrument face. The decal for it goes on here. This is the room that you need for your pointer. Some of these have like little extra bezels that go up in here. And of course, here's that all-important outside bezel. And you can set this height here by determining how far down this goes. And you just have a lot of adjustment, but none of this is handwork. This is one of these little parts. And basically, you know, that sets the front. You put your decal on it. Notice there's no pointer. And then you come back in with your with your bezel. You put on your little pointer, which is also 3D printed, and the bezel drops right down, and it's like perfectly aligned. You get all the right clearances. Here's the only one I had that's all put together. This is with the pointer and everything else. And you can see you can even do it on little tiny ones. You can make these things, you just make a sack full of these little things here. You can make a whole tray of them in a couple hours. You don't have to, there's no duplication of work. And then when you're done, this thing just pops in the back of this thing, and it fits very carefully, just like all the rest of them. They're extremely even. And then on the front you get this very even effect, and you also have the depth of the gauge. You can even do like turn and bank indicator. You can do them with three-dimensional characteristics. Here's one that has a little part that I cut out of FR4, a little detail. This is from that same machine that cut the hole. It can also cut little things like this, and this little piece here goes underneath the glass, like you see it right here in the corner. This goes in there like that. That's all cut out of this same material. It's like, who knows, it's probably 10 thousandths thick, and that's what goes up inside there. There's a little tiny 3D printed pointer that's in there, and you only are able to do that because you can set that depth just exactly by the combination of that base and this little trimming feature. So here you're using a 3D printer, you're using a desktop CNC. That little 3D printer that did this probably only cost $200 now that I made these on. Vacuform machine used to be kind of hard to get, or you had to make it. This is using this small Vacuform machine that I think dentists and orthodontists are using. You used to be able to get it for like $150. The actual decal material, this is done with just like a regular laser printer, but you can print out all the faces without any of the needles. And then what's hard to see here is this is actually cut out on a like a Cricut, I guess they call it now. I have a different brand, but all of these little decals are already cut to the exact dimensions, and when you kind of mount, they fit right in there just perfectly. There's no trimming, there's no handwork at all. Everything just kind of snaps together, and you just use some RC56 to hold it. Comes out nice and clean. Hope that helps.